Thank you for the introduction and for the invite. Actually, I have a slide to quickly introduce myself. How I call this slide is normally a short introduction of me in Logos. As Nick said, I have a background in computer science. I did a PhD in machine learning. I've been working at University of Bristol as SRA. I'm actually fellow of the Software Sustainability Institute. And this is where actually I got my interest in reproducible serving machine learning. I'm also very much involved into the Python community. I've been organizing many events throughout the years, like it's like 15 years now, like PyCon Italy, EuroPython, EuroSAPI, you might have heard some of them. And now I do work as developer advocate, and today I'm going to be speaking about the wonderful job the folks in the Conda community have done. And I actually want to start with a question to all the folks in the room. How many of you use Conda for the data science or machine learning environments? All right, so more or less for those on the internet, more or less half the room, shall we say that? That's exactly what I was expecting. And for those of you not familiar with Conda, essentially Conda is started as the name of the tool, but Conda is actually more a community. And throughout the year, the name is actually referring to an entire open source packaging ecosystem and philosophy. These ecosystem is actually supported by many organizations nowadays, and these organizations share the same goal of providing easier access to programming tools and libraries. So conda.org is the reference website, and within these initiatives, it does exist Conda Forge. Conda Forge is indeed the community-led recipes, infrastructure, and distributions for Conda. And you can have briefly look at the statistics this website has. So just like monthly download, we have 134 million. Just to give you a little bit of statistics about what we're talking about. And why I'm mentioning this, because recently announcement, and you can find this on Char's blog post on flower.ai/blog, Flower is now available as a Conda package on Conda Forge. So if you're using Conda as your development environment, you can install Flower directly from the Conda Forge repository. So going back a little bit to what we were talking about, so portable and reproducible deep learning environments. I'm going to focus very briefly on what I mean by deep learning environment and by using a very foundational deep learning environment. So normally what you want to have, well, of course you want Python. So you have, for example, Python 3.11. And we're going to install in this environment a few other common packages like Jupyter or IPython. Of course, we can have our deep learning of choice. I'm going to go for PyTorch, because that's my favorite nowadays. So you can have PyTorch and Torch Vision, for example. PyTorch has dependency with NumPy, so you also get NumPy. And, of course, Flower. So we're going to consider this as the reference deep learning environments. The Conda way to create this environment is you fire up your terminal, command line, and you do Conda create. -n is the option for the environment. We're going to have lots of creativity. I call it GL environment. And then you can list the list of packages you wanted. And if you run this one, essentially what you're going to get is an environment containing the list of packages. You may notice that what I did when I installed this environment, I actually specify the version only onto the Python version. The rest of it is essentially taking the latest release. And this is essentially how we normally start with things, unless we have specific requirements. So you get started with this environment, this is exactly what you get. Interestingly enough, though, why I'm trying to explain why I'm talking about this today. Essentially, when you why specifically deep learning? Well, deep learning is a very interesting use case. Certainly, you have different development stages. So imagine that you have this environment, and you want to, first off, have the very same environment on prototyping stage. So we're talking laptop. Let's say we have a Mac OS laptop. And then we want to use this environment for training of the model. And maybe we want to go to a Linux server, so it's a different operating system, and also different architecture. And also the packages for deep learning, we want to use GPU. And what about inference? We want to move to a server, which is, for example, I don't know, AWS Graviton, even another target architecture. So what we really want to do is, first off, we want to have an environment which is easy to install on every single platform we need. And that's exactly the portability we're talking about. So we want to recreate this environment easily on multiple platforms. And by platform, I mean any combination of operating system or hardware architecture. So for example, what we've been considering OS X 64 as the laptop, OS X ARM 64 as the inference server, and Linux 64 as the training server. But at the same time, we want to make this reproducible because, for example, to guarantee reproducibility, we want that each specific versions of library in each of the supported platform is going to be the same. So for example, if we're going to training PyTorch on Linux server, we want to have PyTorch with CUDA, and we want to specify the version of CUDA we're using, like 11.8. If we're going to the inference server, we're going to have PyTorch with MPS backend support. If you're going to laptop, we want to have PyTorch with CPU support, and maybe if we have Intel CPU, we can have MKL acceleration on those. So as you can see, one single package has many flavors, depending on what is the target architecture. But we don't want to, we essentially need to have a method to seamlessly support multiple platforms and guarantee full reproducibility. So in Conda, normally what you do, well, the first thing you could do is like Conda env, if you want to export an environment into a file, the so-called environment.yaml file, and for those not familiar with this format, the file you're looking at is in YAML file format. So if we do something like that, it, of course, it's portable because that's how Conda was designed in the beginning. So you want to easily recreate the multiple environments on multiple platforms, but certainly it's not reproducible. Well, of course, we don't have any version number, so this is not going to work anyway. We can do something better, still using Conda, and we can do Conda env export and remove the builds number from packages. This is fairly technical, but this is a very good best practice because normally the build number is going to change depending on the platform, and is not really interesting if you move into multiple. It doesn't really gonna matter if you move on multiple platforms. But if you do something like that, you do have an export of the entire environment. So lots of packages we never installed explicitly. So it's certainly not easy to handle. And so perhaps this would be a better representation of the environmental YAML file. So we could get the previous result, manually modify that, and so at least we have the list of packages we originally installed with the version numbers. And this is a starting point. This is a very good starting point, but still we have a problem. How do we handle the case of having PyTorch installed with different flavors on multiple platforms? So where's the CUDA Linux on Linux machine here? And so I want to introduce, in case you're not familiar with this, I want to introduce a fantastic tool the Conda community has developed. It's called Condalock. Condalock is essentially a lightweight library that can be used to generate fully reproducible log files for Conda. So starting from an environment.yaml file, what you can do is, so you have Condalock, you pass in the environment file, and then you specify what are the platform you want to target. So in this case, we want to target from this environment the platform of the laptop, OS X 64, and the platform for the inference server, OS ARM 64. These are the two platforms that don't require CUDA and GPU support for PyTorch. If we want to include also a target for a new platform, say Linux 64, we could do something like within the same session, we can run this command afterwards, like including Linux 64 of the platform, and include the option ---- with CUDA and the version of CUDA. Why we do that? Because of course we have Linux, so we can have everything we wanted. We can have PyTorch with CPU on Linux and GPU. In this particular case, with one GPU. So the result of these two commands is a Condalock file, normally named condalock.yaml. And as you can see, this is just an extract. As you can see in this log file, this is just a snapshot for Platform 64 and PyTorch. I'm sorry it's not entirely readable, but what you would read there is like you have the name of the package PyTorch with CUDA installed there. So for Linux 64, in this log file, you have the PyTorch with CUDA support. And actually, if you look at more carefully, you have, for the laptop, you have PyTorch with CPU and MKL. Sorry if that's not readable in the back, but trust me. For Linux, you have PyTorch CUDA. And you can immediately see that the dependencies these two packages have are very different because they have different dependencies. And OS ARM64 has a CPU generic, which means MPS backend. The main advantage of doing Conda log files, apart from being fully reproducible, is that log files contain directly the URLs of each packages, meaning that whenever you're going to replicate and reproduce this environment, you don't have to do resolving of the environment at all. It's just like downloading the packages and that's it. It works immediately. All the environment has been resolved already for you. And in fact, if you want to use it, to reproduce the environment, you do conda log install, you pass in the prefix of the platform you want, and then the name of the conda log file you're using. And if you make it portable, you can even generate from the same conda log files, you can generate the rendering of the environment for specific platforms. So like conda log render, -p Linux 64, it generates your new log files specifically for the Linux 64 in case you don't want to have everything within the same file. And that's all I have. Thank you very much for your kind attention. I will be posting the slides on Conda Incubator, which is the repository of conda.org where all the resources about Conda are being posted. And I'm hoping for any question if you have any. Thank you very much.
Thank you. We have time for a few questions. So questions online, perhaps? We're looking. Let's take an in-the-room question if we see one. Yes, the gentleman down there.
So I'm just curious how long the package is actually kept in a Conda community, for example. Like, I mean, there's a version like 2.0 and then 2.2, blah, 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 and then maybe the old version is going to be maybe deleted, right?
Yes.
And then my further question is, if that's deleted, like in this case, maybe one of the package is kind of outdated and then maybe it's caused some error, right? Then in the end, actually have to maybe manually fix the conflicts on packages. So it's also like discussed about like this type of...
Yeah, that's an excellent question. So the reason why CondaForge exists is because essentially the people working on CondaForge, they make sure that all the dependencies are guaranteed for all the packages that are there. So whenever you're getting any package from CondaForge, you're absolutely sure that all the dependencies will be resolved. So the package is going to work. In terms of maintenance, so in long term with different versions, it really depends on what is, well, first off, it depends on what is the support that each package has, like by themselves. So like if anyone is willing to take on the responsibility to maintain any package, it's really community driven. So it's really a community effort, getting the best effort to maintain a specific package. Normally, every package in CondaForge undergoes a very thorough process. So like before getting onto CondaForge, which is really the community reference recipe and repository of packages, you have to guarantee that the package is maintained, and then there's a full ecosystem around it. Otherwise, normally what you can do otherwise is like every single user can have their own channels. And then you create, I think this is hosted on a Conda platform though, you can have your own channel and you can maintain your own package. So you're free to do that without, and people can install packages directly from your channel. When you install packages using Conda, you have this option of using different channels, and CondaForce happen to be the community one, but you can customize as many as you like.
Thank you.
Great. Any questions online? Perhaps not.
There's one there.
One there. Just let's keep it brief.
Thanks. Actually, I have a question. After every installation of a package, Conda becomes slower and slower and slower. So is there any way we can increase the speed, or is how?
Yes, that's also a very good question. So Conda has been, so the slow part of is not actually the installation, is the environment resolving. So because whenever you need to install a package, what Conda tries to do, and I essentially briefly mentioned this in the beginning, so when you want to install packages, you have to resolve a long list of dependencies. And so that's what normally takes time. Although Now Conda has changed the engine in the backend, so it's not using the old engine, it's using a new engine based on Mamba, and that is again a community effort, like joining forces together, Conda and Mamba community. Essentially, they are part of the same community. And now, if you the Mamba solver is default in Conda, so even if you resolve a package, it's pretty fast. But another reason why you want to do, once you've done all the resolving packages job, if you use Conda lock, you don't have to pass this step anymore because the package is already there. So the lock files is not like a list of names of file, it's a list of dependencies with specific URLs to each packages. So you just download it and install it. So that's it. That's another reason why you want to use Conda lock.
Okay, that's all the time we have, but thank you so much. Great talk, love it.